Okay, the dreaded negative numbers. What an interesting lesson I had with my children teaching negative numbers, and I thought it would be a good opportunity for us to go through some of them. I put some questions on the board. I actually put the questions that you'll see on the left-hand side: 4 minus 10, 2 minus 3, 3 minus 7. And like all diligent children, they said, oh no, of course not. You can't do 4 minus 10. Why can't you do 4 minus 10? Well, you know, you can't minus a negative number. Or you can't minus a number that is larger than the number you're subtracting by. What happens though if context comes into play? So what happens when negative numbers come into play? So let's have a look at this first question over here. 4 take away 10. Now again, when you look at that in a question, you're always told to say, oh, make sure that you're subtracting a number that is smaller. But when you are telling the children they can go into negative numbers, how do we end up doing that? Well, I would always say from the off, use a number line. Very, very important that you use a number line. We use our starting point here, 4. Now, what kind of context are we going to be using negative numbers in? Well, I can think of one straight away up from the off. Temperature. Temperature is the one question that you're always going to be asked with regards to negative numbers. You're going to start off at a temperature. It might get colder by 10 degrees, or you might be asked the difference between two temperature amounts. So in this regard, we might have a temperature of 4 degrees, and overnight it gets colder by 10 degrees, which means that it's going to be 4 take away 10 degrees. Now how do we do that? We go into the negative numbers, which are the numbers that are less than 0, they go past 0. So we start at 4, and we're going to just take 10 jumps. We make sure we're jumping 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 take away 10 equals negative 6. How about 2 take away 3? Oh no, we can't possibly do that. Well, yes we can, because negative numbers do exist. And depending on what the question is being asked, then you'll understand what you need to be doing. So 2 minus 3, your teacher might be saying, okay, we're going to go into the negative numbers, or we're going to say 2 degrees and it gets colder by 3 degrees. What temperature will it be? And we know that temperature goes into the negative amount. So again, we're going to start on the number line at our 2, which is our starting point. And then we're going to jump 3 degrees down. 1, 2, 3. So 2 take away 3 degrees equals negative 1. And actually, they might be asking you to do this size. Again, one final simple example. 3 take away 7. We want to go into the negative numbers. Always the best idea is to use a number line, especially in primary school level, where using negative numbers might not be the most natural thing for you to do. You identify where the number 3 is, and it's simply just counting back now. We're going to count back in 7. 1, 2, 3, 4, 5, 6, 7. That means it is minus 4 after 7 is taken away from 3.
So with negative numbers, they never work the way you think they're going to work. So what I always find is children always want to do this in their head, but it doesn't work like normal numbers. And I'll just say you need to draw your number line, and you need to do it on a number line, because otherwise you'll make mistakes. You can just scribble a quick number line, can't you, Mr. Blom, in a test? It doesn't take that long. You don't even have to draw the line, just do the numbers.
Yeah, I think I think number lines are almost underused. And they're really good ways of absolutely making sure and pinpointing what's happening. And it's also good at identifying with the journey that the numbers take from one point to the other. Okay, so let's go back to 3 take away 7. So you've got 3 and you're taking away 7. Your teacher's clearly asking you to go into the negative numbers, and this is a negative number question. You're going to go backwards, and so I'd always start from the right hand side, because it creates more of a realistic idea of what you're doing. The number is getting smaller, so it's going further through into the negative numbers past the 0. So what I'll do is I'll write my 3 over here. So let's go down 7 from 3. 1, 2, 3, 4, 5, 6, 7. Now, as you can see, I've jumped perfectly to each line of each block to make sure that I know that I'm making equal jumps each time. And then it's about making sure I do my counting correctly. Now this is where it possibly could get quite tricky, because we're going to 0, and then we're going to go into the negative numbers. So it's 2, it's 1, and then it's 0. From 0, it becomes -1, -2, -3, and again, as in the last question, as in the last example, the same answer of -4.
An example of a very quick way of doing this, once you've had a lot of practice and you know what you're doing, 4 minus 10. The question is 4 minus 10. We can just write the numbers. 4, and I'm just going to draw the number line. Now I don't know exactly how fast I'm going to go back. I've just drawn the numbers this time, and actually I've not used the squares or the blocks properly because it's a different method, you see, this method. I don't know how far I'm going to go back, so I'll just keep going, you know? I don't know what I'm going to need. So really what I've done here is I've made a number line without the numbers. Then you can go back 10. Don't count the one you start on, so go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I'd been more neat, that would probably be better, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Little do we know that operations are generally quite fluid. So in terms of how we can put numbers in, we always look and think of 1 plus 1, 2 plus 2, 2 minus 1. We don't really think of how the numbers are written here again on the left-hand side. They can be written like this, and they are written like this. And we're going to have a look at how we can possibly do that. Again, utilizing the number line. So let's have a look at the first question on the left-hand side. It says -7 plus 6. Again, it's a very simple tool, this number line method, but it ensures that you're going along the right path, and it actually gives you a good contextual understanding of what's going on. I'm at -7, let's say -7 degrees, and then get 6 degrees warmer. You're adding that 6 degrees to the -7. So let's have a look. We identify where the -7 is, and obviously you're going to be drawing these number lines yourself. This is for time. And we count 6. 1, 2, 3, 4, 5, 6. Notice how the numbers are going to the right-hand side as a result of the number being added. So when the number is being added, we're going along the right. When the number is being taken away, the number is going down the left-hand side. The answer then is -1. What about number 2? We start at -9 and we add 3 to it. 1, 2, 3. The answer is -6. And finally, we're going to look at -2 plus 7. This might be quite interesting because it's going to go across that 0 mark into the positive numbers, which I'm really excited to show you. We start at -2. We're going to jump 7 times. 1, 2. So it took 2 to get to the 0. 3, 4, 5, 6, 7. So therefore, my answer is +5. You don't have to write the plus sign because a number that is just by itself is indicated as positive, but I'm just doing it there to show you as an example. Could you also have a negative and then subtract a negative number? Yes, you can. And Mr. Saul thought Mr. Saul thought I was cheating a little bit. So what I've decided to do now is I'm actually going to draw my own number line and show you how you can do it there. So we've got -4. We know -6, the number is getting smaller. Therefore, the jumps are going to be done to the left. We identify where -4 is, and we're going to do those jumps. We're going to do 6 jumps to the left, -6. So we're going to go 1, 2, 3, 4, 5, 6. And then we can count. -5. Now that's a very, very important point. The number is getting smaller. If you think about it on a trajectory, if I'm thinking -4 degrees, the temperature is getting colder. It's not going to go to -3. It's going to go to -5. It's going to then go to -6, then to -7, then to -8. We're not going up back towards the 0. So you need to make sure you're very careful about that. So the number's getting cold. The number's getting colder. The number's getting smaller, which means it's going further into the negative numbers. Just because 10 is a larger number than 4 doesn't mean that -10 is not a smaller number than -4. -10 is definitely a smaller number than -4.
-10 is colder than -4, isn't it?
Definitely.
So smaller.
So if I'm going -4, I'm taking away another 6. Is -10 less than those two numbers? Yes, that means we're getting into that's when we're getting further into the negatives, which is very important. How about -9, -1? Again, it's about identifying what's happening. This number is getting smaller. Now, is it going to go, I'm going to give you 2 options here. Is it going to go to -10 or is it going to go to -8? Now, just because 8 is a lesser number than 9, it is definitely not. Because the further we're going towards the 0, the more positive the number is going to get. So therefore, minus 10 is moving further into the negative numbers, which means the number is getting smaller. The answer is minus 10. And finally, minus 5, take away 6. Again, we need to go to the left. We need to jump to the left. So we've got minus 5, minus 6, minus 7. We're going to do Mr. Saul's way. Minus 8, minus 9, minus 10. I'm just going to write a couple down, and hopefully that should be the right amount. So we're going to do the jumps, right? We're going minus 6. 1, 2, 3, 4, 5, 6. The answer is minus 11. So another way in which you'll be tested using negative numbers is that you might get a question which asks what the difference in temperature is between two different places. And I'm always shocked at how the lack of understanding of context affects someone doing the question. So I'm going to talk about how we understand how this question is done. And the best way I'm going to do is I'm going to give you two examples. Two Disney examples. We've got Frozen and we've got Moana. Moana is a one. Yeah, Moana. Sorry. Frozen, very, very cold place. Arendelle, I believe it's called. Very cold place. We're going to say it's in the negative temperature. And we've got in Moana, I believe it's around the area of Tahiti. So it's going to be warm temperatures. So what we're going to do is we're going to find the difference between Arendelle and Tahiti. In Tahiti, it's 33 degrees, and Arendelle's minus 23 degrees. Now, the kind of answer I see very regularly when it comes to these kind of questions is I see this happening. I just want to kind of look at this misconception very carefully. Is that I see 33, and then I see minus 23, and we get the answer of 10. And people would say to me that the difference in temperature between Arendelle and Tahiti is 10 degrees. Well, let's have a look more carefully at how this possibly could be the case, utilizing a number line. So instead of just trying to work it out using any form of just compact method, I'm actually going to use a number line to ensure that I understand fully what's actually going on here.
Because you can't use standard written methods on negative numbers. You need a number line, don't you?
No. I'm going to have the higher number on the right-hand side. I'm going to have the lower number on the left-hand side, so it gives an accurate representation of what's actually going on. In Tahiti, it's 33 degrees. And in Arendelle, it's minus 23 degrees. And just because we hear the difference between two numbers, we immediately think that it's going to be subtract. Is that correct in this instance? Well, let's think about it in this way. We're looking at the difference between these numbers. We're looking at the journey from either here all the way down to here, or the journey from here all the way down to here. Because the difference is going to be all this bit in the middle, all the stuff in the middle of these two numbers.
It's the same as distance between, isn't it?
Absolutely, absolutely. So that's what we need to do, is we're actually going on a bit of a journey here, and the number that is the difference might be actually quite large. And despite it being difference and essentially a vocabulary that is associated with subtraction, this number might be larger than either of the numbers in the question. Why is that the case? Well, let's do a little bit of a calculation. What I always tell my children is, write a 0 in between the two numbers. What is the journey from 33 degrees in Tahiti to 0? Well, we know that 33 taking away another 33 is going to be 0. So therefore, this amount here is going to be 33. Now, have I found the whole difference between the two places? Well, I haven't, because I've only gone from 33 to 0. I still have a whole other difference of minus 23 degrees. Well, shouldn't we then travel across that amount as well to get the full difference? Yes. What is the distance from that 0 to minus 23? It's 23. Now, wouldn't I say, then, in conclusion, that the distance and difference between these two numbers will be whatever these two are together? Three plus 3 equals 6. 3 plus 2 equals 5, which makes 50. And my answer here is 56 degrees Celsius. Well, let's have a look at this in a context, in a situational environment. We've got the freezing cold of Arendelle, and we've got the really hot temperatures of Tahiti. Minus 23 degrees and 33 degrees. The whole big difference there, 56 degrees Celsius. That is the difference. So let's put that into practice and do a couple more examples very quickly. We've got South Africa, which is 26 degrees, and England is minus 3 degrees. What is the difference between the two temperatures? It's going to be more than 26. The difference is going to be more than 26 because in order to get from 26 to minus 3, you have to do a whole 26 and then a little bit in the negative numbers. How we can work that out is we write 26, 0, and minus 3. That's what I always say. Write the three amounts. And then we're looking at the distances. Minus 3 to 0, you can do it either way, is plus 3. And 0 to 26 is plus 26. Therefore, the difference in temperature is 29 degrees. What happens if you can't use the 0 as a kind of way of finding out the difference between the two? You can just take your time and do your counting steps. So we've got Norway, which is minus 13. Now, minus 13 is the larger number, so we need to put that on the right-hand side. And Greenland is minus 20, which is the lower number, which because it's further into the negative numbers and further away from the 0. And we just count from there. We just count between the two. So we can say one point to another. So we can say minus 13, minus 14, minus 15, minus 16, minus 17, minus 18, minus 19, and minus 20. And I can just count over here to see how many jumps I've made. You could write all the numbers down as well, which is probably the better way of doing this, but I'm just doing it nice and quick to show you the way. The difference there is 7 degrees.
So we've talked about difference between being the same as distance between, but other things that also mean the difference between is if it says how much colder or if it says how much warmer, they're all just difference. So they all use this method.
Yeah, perfect.